Good day, guys. Today I will give a presentation for you guys. I'm presenter of Team SAR, and my team member is Jung Shi-hoon and Lee Jae-eun and Lee Sun-bin. Today I will be frustrated to make an English presentation. Anyway, today I will explain about synthetic aperture radar. Contents is first is principle of synthetic aperture radar, and second imaging processing of SAR, and third is question and answer. First, the principles of SAR. What is SAR is synthetic aperture radar is definition is satellite itself illuminates microwave and then sensor receive backscatter signal. And first is radar system, and radar system must be coherent. 움직임이 없어야 돼요. Phase information is preserved. And third one is two dimension. It simply says 가로 세로, and azimuth resolution is independent on range distance. Azimuth is the moving direction of satellite, and on range distance. Range distance 독립적이에요. 서로 독립적으로 resolution. The radar measurement principle is first the satellite right signal is same velocity as light, and then receives echo signal. It's backscatter signal of image object. It simply says radar reflectivity. Radar transmits pulse, and first the radar transmits pulse, and second the radar receives the backscattered signal. We only focus the two words. The first is positive number. There is a focusing on a backscattered energy towards the radar. Its signal is positive number, and also focusing of backscattered energy wave from 벗어나는 에너지는 negative number. C is first is directional pulse, and then durational pulse. This is really important signal to make image, and the third is backscattered signal. We can see two signals about the return from house. It's bigger houses, bigger signal than tree. Tree signal is really smaller than house. And backscatter coefficient, like a bigger object can have a bigger backscattered signal. The very high backscatter is like a building, and low backscatter is like a lake, smooth surface. Because really smooth, so signal can scattered at every way. Last one is imaging processing, and azimuth resolution have a half antenna length in azimuth. It simply says antenna 길면 resolution is good. 안테나에 따라서 resolution이 비례해요. And range resolution depends on the bandwidth or pulse duration of transmit signal. And plus incidence angle. Incidence angle is this angle is 수직 and 입사각. And azimuth resolution depends on the azimuth size of the radar and increasing with range. As I said before, bigger size antenna can have a good azimuth resolution. And formation of synthetic aperture is same satellite, but it moves from direction of azimuth, so they can detect same object 1 and 2 and 3. They pulse the signal 1 time, 2 times, 3 times. So they can't make image this point. For example, SSAR can pulse 1,700 pulses per 1 second, and it has a 30-meter resolution. You can see this is point scattered is like a building an object. After that, satellites can measure the signal, and then that features like a lead lines here. It's a really difficult mechanism to understand because they have a two process migration and convolution. So and then they get a signal and then process like that way. The low data is like this, is circular features, and then range compression 줄이고, azimuth compression 줄이고, and then they can express like an object like a dot. And also I said far range and near range. The terrain illuminated nearest to the aircraft in the line of sight is called the near range. And then the farthest point, farthest point of terrain illuminated by the pulse of energy is called the far range. And it is frequency bands of SAR. Mainly they use the C band and the P band, anything else. Finish question and answer.